This video was brought to you by Embedded System Solution, a company composed of like-minded electrical engineers, computer engineers, and computer scientists, and whose main goal is assisting our engineering customers, non-engineering customers, and technician level customers with their electrical and computer engineering level and technician level needs. Our customers range everywhere from engineering students to university professors, technicians to engineers, junior engineers to senior engineers. Please feel free to visit us at www.embeddedSystemSolution.com. Again, www.embeddedSystemSolution.com, or better yet, email us at support@embeddedSystemSolution.com. And like always, don't forget to subscribe to our channel and like. His information is stored on that shadow file, his username and his password. And so whenever you try to do Authenticate, of course the server is going to do a comparison to every single user and every single password right there. And if it finds a match, then it says authentication passed. Now, so the question is, if the password goes through a hash algorithm and the output is hash, what is exactly hashing? So for you to understand password authentication, you have to give it a... So anyways, so hold on, I'm getting ahead of myself, right? But every single user, the Linux operating system, whenever you're creating the account and it asks for the username and password and you enter that username and password, Linux does not store the password. Because remember, whenever you do authentication and that signal is being received, it has to do a comparison to an existing information, right? So whenever you're creating your username and your password, whenever you're barely creating the account, whenever you put the password, Linux in the shadow file does not store the password. It stores the hash value of the password. And you might say, why store the hash value? Why not just store the password? Well, because if somehow somebody... Well, I'm getting ahead of myself, right? So, hold on. So, it's the hash value. The only thing that you have to know is that when you create the account and you put the password, Linux does not store to that shadow file. It does not store your plain text password. What it does is it runs it through a hash algorithm, and the output of that hash algorithm is what gets stored in the shadow file. So just keep that in mind. That's the only thing that I want you to memorize, right? And so every single user account, whenever you create the account, every single password that they put, it's right there in the shadow file. So in this case, I can tell that there's three user accounts in this particular computer, correct? And so anyways, so let's talk a little bit about, so this is something tangential, but let's talk a little bit about the hashing algorithm. What's the big fuss about it? Why do we use it? Why do we need it? What's the purpose behind it? Oh crap, I didn't move it. Okay, I'm sorry. Let me move this to the right, because sorry. Okay, so now we're going to talk about the hashing algorithm, and we're not going to do a mathematical rigor, so don't worry about that. So no, that's not what we're covering right here. So this is a hashing algorithm, right? So hashing algorithm, it has an input and it has an output, correct? Now, the input to the hash algorithm, you could input whatever you want. You could even put that letter A, an ASCII character, like in this case, right? And so if you don't believe me, check it out. So this is an online converter, right? So if you put on, if you put that like hash online, it gives you online generators, right? So you can put the value in there. So it's freely published. Now, if I put the letter A, that's the hash value. But if I go to another website and I put A, notice the hash value. What do you notice about it? It's the same. Now, if I put the letter B, is it not the same? So that's the thing about the hashing algorithm. You could put, and it's going to generate a hash value, right? So the input to the hash algorithm can be as short as you want, from an ASCII character, to as long as you want, to even a file. The thing about a hashing algorithm is it doesn't matter if you're just putting in one character or a file. The output is always going to be a hash value, and it's always going to be a long hash value, essentially, equal in bits. It doesn't matter how big or how small. Now, Another thing about hashing is that, well, let me see if I'm forgetting something, anything. Okay, another thing. Am I forgetting anything? Let me see. Yeah, so you can put information as small as you want and as long as you want, right? But the thing about a hash, so anyway, so you could put the letter B, it generates a hash value. You put a file. Oh, that's what I was gonna say. You put a hash value. Now, let's suppose that file, the file that we're inputting, this file, it's 1,000 ASCII characters long, and then it generates that hash value. And then we put another file that has 1,001 ASCII characters long. Common sense will tell you that the hash value of that file should be almost the same. In fact, the hash value of the letter A and the hash value of the letter B should be approximately the same. After all, there's just one letter difference in the alphabet, and the two files, they should be approximately the same if it's just one extra ASCII character. Well, the thing about a hashing algorithm is that just one character changes, and the hashing output, the hash value, is completely different. So that's the thing about the hash value, that it's complete. And one thing that I haven't mentioned, that's the heart of a hashing algorithm, the reason why we use it in terms of password authentication and in the shadow file, is because it's a one-way function. What is a one-way function? What is it? One-way function basically means if I have the hashing algorithm and I had the hash value, even if I had both, there's no way for me to get the input, like go back, do the inverse, and get the password or whatever was inputted to the hash algorithm. And this, to me, I could not make sense of it, because I do have a minor in mathematics, right? And I was always taught that functions, there's always the opposite function, right? So addition, there's subtraction. Multiplication, there's division. Integrals, there's derivatives. Everything has an opposite. Well, it turns out there's some functions that don't have the opposite. You can't go back. Once you go forward, you can't go back. Think of modular arithmetic, prime factorization, stuff like that. So hashing algorithm is one of those things that even if you're to be given the hashing algorithm and the hash value, theoretically speaking, there's nothing that you can do to the function that you can produce the output. Now, these hashing algorithms, they're freely published, like I just showed you online. Anybody can grab it and anybody can use it. But the thing is, there's no way of you going back. And so, to me, it begs the question, okay, let's go back in time, right? So if there's no way for you to go back with even if you have the hashing algorithm and even if you have the hashing values, then what is the big fuss, right? Well, the big fuss, and everything's encrypted, whenever you use username and password, the big fuss is, let's suppose someone steals that shadow file, right? Somebody hacks into that computer, and somehow they steal that shadow file, and they have the hash value for every single username and password. And let's suppose it's a company like Twitter, right? Where you have millions of passwords, right? Theoretically speaking, as a theory, as I just mentioned, even if you have the hashing algorithm and you have the hash value, you can't revert it. You can't go back in time. You can't get the input to the algorithm. Well, this is the thing, the weakest link. Even though you can't reverse it, what you can do is you can experiment and put like the letter A, get the hash value, B, put the hash value, C, get the hash value. And then use a dictionary. That's why they call it dictionary attacks. You could put Apple, get the hash value. Car, get the hash value, bro. And you go through all the dictionary and you get all the hash values. If you were able to somehow grab that file and what you're going to do as a hacker is you have the hash value. You're gonna generate the hash value of common words like the dictionary words and see if one matches. And believe it or not, there's going to be an account, somehow, that for the password, he's going to put Texas. Of course, it's going to be easy to... But it's not that they reverse engineer. They didn't reverse engineer. There's nothing like that happened. What happened was they had the algorithm, they had the shadow file, and they just did a trial. Like they went through all the iterations that they can think of or that it's in a dictionary. Remember, you're using computers nowadays to do this. And so they have those values stored in a table. And for every single entry in the shadow file, they're going to do a comparison to all the entries in the table. And eventually one is going to match. And if you have one that matches, then it was worth all the time that you took to hack into that computer, grab that file, and do the dictionary attack. Because guess what? If you have the username and the password, because the username is openly available in the shadow file, and the password, then chances are that person, for their banking account information, they use the same username and password. For their retirement money, social security money, they use that password and that username and password. For their stock, they use that username and that password. And the list goes on and on and on. And so the problem with username as password is not so much that it's username, because remember, the information is being sent encrypted, and theoretically speaking, even if you had the hashing algorithm, you have the hash value, you still can't go. The problem, the weakest link, is the users that create a simple password. That's one of the problems, actually. So if I were to actually talk about the whole thing, it would take me hours for it to mention it. But that would be one of the problems. One of the problems is that the user, if they steal it and the username happens to put... Now, if for the password you put something like car, blue, USA, France... Yes? 1 second. Yes? No. Oh, okay. ¿Cuánto tiempo lleva ahí?
Acabo de llegar, hijo.
Oh, okay.
Te toqué, es que acabo de llegar.
Espérame, antes que se me olvide el hilo, ¿eh? Okay, so the problem is that users that create simple user passwords. So that would be one of the problems, right? So, but theoretically speaking, if you create a hard username and if every user were to create a hard username and a hard password, then we would be having this talk, right? And so, oh, and I know it's too late to mention, right? But the thing about a hashing algorithm is it never repeats. So if you put the letter A, it doesn't matter if it's an ASCII or a string, it should never repeat the hash value. The hash value, theoretically speaking, should never repeat. So as long as it's a different, if you put the same input, it will always repeat. But if you put a different input, the hashing values, theoretically speaking, will never repeat, ever. That's theoretically speaking, right? So anyways, here we talk a little bit about the hashing algorithms, the ones that exist, and just remember they're one-way functions. And so hopefully this explains the delicacy in terms of using username and password, right? So now we're going to talk about SSH keys, private and public. But one thing is, so hopefully you saw that, you know, the whole concept of username and password, and how is it that the shadow file stores the MD5 value of the password. And as soon as you create the username and the password, what actually gets stored whenever you enter the password is never the password. The password in plain text gets discarded as soon as you create it. The only thing that's saved is the MD5 password. You know, so anyways, hopefully you got it. Thank you for seeing. Bye. Let me see, is this it? Yep, this is it. Thank you. Bye. Ya nomás me falta un video, pa.